This is the MIWA WR. It's a double sidebar slider lock made by the MIWA lock company. There are two sidebars, left and right side of the core, and there are sliders, sprung sliders inside this lock. Also on both left and right sides. They can either move upwards or downwards depending on where they are located inside the core. This is how the key looks. It has interesting looking cuts. These cuts lift the sliders both on upper and down side of the core to the corresponding height. You can put this key in like this, and this is a dual sidebar, so this relocks at a 180 position, and the key can be removed at that state, same as like the MIWA DS. Now, I would like to talk about this lock more, but that would probably require to disassemble this lock, so I will try to pick this on camera first before moving on. Okay, it is open. As you can see, it is actually not a very complex lock in mechanism wise, but it's actually really tricky. At least it was tricky for me to pick, and I will explain why that was in just a minute. Basically, this is almost same as on all MIWA locks. Like, for example, there's also this U9. Basically, you tension from the front of the lock. Like you would you put a tensioner in here. Do I have a matching one? Yeah. So you tension the lock like this. Then the back of the lock stays compared to the front of the lock. That means that you twist the lock, but you don't twist the whole cylinder regularly. So the front turns more than the back part, which makes the front ones bind earlier and the back ones bind later. Now the problem is that if there is a a high lift element that there are false gates, then that means that the back of that the element on the back is going to bind very later on after you've picked most of the stuff on the front. The problem is that you after pick up the element that binds on the back, if it falls into a say a false gate, you have to relieve tension to make that back lever or element unbind from the false gate to lift it up with the true gate. Now that, of course, is mostly going to drop almost everything on the front, which is probably similar on this lock too. So there was this final innermost lever that was keep binding, and I just couldn't lift it without like dropping every single one. So eventually I reached in deep enough with this high lift hook and I was able to pick it open. Anyways, it's open, so enough talk. Now let's disassemble. First I will adjust the angle to the better angle that I can disassemble this lock. Let's see, do this and do this will be probably enough to disassemble the lock. Now this is a standard MIWA format that you see on a lot of the MIWA locks like the U9 or PR. You have this little springy piece and this actual core is inside this housing. First, what you have to do is remove this circlip, which MIWA uses a lot in their locks. I have this Chinese circlip plier that is just good on removing this. Hang on. There we go. Just pops it out like easy. Let's get the pinning tray here. After you remove that circlip, you can just pull the whole core out. This is a metal ring. This is the core and this is a housing, which is not important now. Now this is the actual lock. As you can see, there is this straight keyway. Let me get it clearer. There we go. There's this straight keyway, but there's this wording on both sides of the lock, which extends into the innermost part, and that actually gets caught in the pick very often, combined with the shape of the sliders that you have to lift. So this is actually really tricky to pick, that I had to use this 50,000s hook because the 20,000s was actually quite tricky to navigate through this very narrow keyway, as you can see. And there are not one but two sides. There are sliders on this side and this side too, and you just basically have to lift like this, and this is really tricky, and the tensioner takes up some part of the lock as well, so that's also that. Now this core cylinder is surprisingly not symmetrical. As you can see, this part is very shallow, but this part this extrusion, this extrusion is more extruded out. The factory setting was, oh, sorry, I almost took that out. The factory setting is that this lock, with the logo on this orientation, the fat extrusion goes like this on the bottom side. I have no idea why did they make it like this, but that's that. Whoops. Again, the lock works just fine. After that, there is this circlip, which I am about to remove. Just like that. Pops out easy. After that, we can take out this tailpiece and the washer. After that, there is nothing that holds the core, so we have to be careful not to get parts flying out. Let me adjust the cam just a little bit more so that it's centered. It's hard. We'll use the key just in case. There are two sliders, sidebars, so you have to grab them with your finger. This housing, there are sidebar grooves for both and nothing else special. This is the core and the two sidebar. I will drop them each accordingly. This one here and this one here. And there are two springs associated to the sidebar, as you can see. I'll show you that a little bit later. At this state, the sliders in this lock is contained. There is a little bit interesting mechanism that holds the sliders, but I'll show you the whole lock first. Now you can see that the hole shapes are a little bit weird. That is because, as I told you earlier, some sliders have to be lifted this way and others they have to be lifted this way. It is fixed in this core shape. This one, as you can see, has to be pushed down, and the holes that look like this have to be pushed up. Now, as you can see, there are a total of 16 possible chambers, 8 on each side, but the lock did not came fully pinned, I'd say. There are a total of 5 sliders missing, so this total count of sliders are 11. Yeah, 11. 16 minus 5 is 11. So this key also is not cut at the chambers that were not filled from factory. So theoretically, if you want to make a 16 slider version of it, you'll have to get 5 max lift levers because the keys are not uncut. Uncut means that they are max lift, basically. Now, if you see this on the side, there are the levers that are populated. And if we put the key in, all the true gates align, which allows the sidebar to drop in. Same on the other side too. Because of the feature, which some can be installed upwards, others downwards, the core is also not symmetrical. As you can see, the shape is different because of how the sliders should be installed. Now, to take out the sliders, you'll have to do some bit of more work, which involves a screwdriver, which I'm taking right now. There are 2 screws on the back. Focus. Damn it. There we go. There are 2 screws on the back. The back plate holds the things that inside this lock. If you unscrew this, you can now remove the true inner parts of this lock. Remove that. Oops, it's magnetic. What the? Oh, it's a piece of shit. remove that, remove the back plate, and we will insert the key again because just in case these sliders go fly and escape. Now you'll notice that there's some weird white thing here. MIWA apparently puts white powdered powdered lubricant in this lock from factory. This thing was filled with that white powder on the back. But yeah, that's that. I cleaned most of it, but some were still remaining. Anyways, the reason these sliders don't fly out even when the key is removed because there are bars that are holding these sliders. As you can see that they are two metal pieces here and here. They are bars that look, hang on, I can remove. There are bars that look like this. They're just literally metal bars that have that little part on the end. And now, after the bar is removed, the sliders can now escape. Just like that. That was the first slider. I forgot to be careful and it escaped. Anyways, that was it's mixed. That was the first one. The second one. The third, fourth one. One, two, three, four, five, six. 6, 7, and 8. Okay. Let me organize them real quick. Okay, that side is done. I just realized that I should not have removed the key fully after removing the locking bar, because if I do that, accidents can happen just like that. So I will remove the key slowly this time and take out the sliders one at a time. I said one at a time, thank you. This is the 8th one. The 7th slider. Oops. Seven, 6 is empty, 5 is up here. That was 5, and 4 is not there. 3 and 2 are here. 3. 2. And 1. All right, that's everything. And now let's take a closer look at the sliders. As you can see, there is a number 2 That means this is a number 2 slider, obviously. There are a total of 4 types of sliders: 0, 1, 2, and 3, where 0 is the max lift and 3 is the minimum lift. As you can see, this hole is a true gate, and there's a false gate also. If you can see, there we go. There's a false gate and a true gate, and the true gate also has this, let's say, some tapering on this side. I can't really show you clearly, but there's a true gate, a false gate, and some tapering, or another false gate, I can say also, that catches the sidebar, so that is also that. This square hole is where that long metal rod is going through the lock, so even if the key and the housing is missing, if the rod is still there, the rod will basically go through that square hole and hold the slider in position without making it escape. Now, the actual part of the slider that the key interacts with is this little extrusion. But not just that part, it is this small angled part. So I'll show you by actually assembling just one of these locks. This direction. Whoops. I just dropped the spring. I'll go take it. There we go. Okay, almost lost that spring, but luckily I got it again. Good. Now I will show you by putting a slider in this lock, just like that. I'll put the bar also in to show you how it works. Basically, if you put the bar, it stays. Now, as you can see in the lock, hang on, let me get it focused a little bit clearer. There we go. You see that little angled bar over there. God, it's hard to see. Anyways. This one. This. Now you see why this is pretty tricky to pick, is that because it is angled like that, so the pick keeps slipping from that angled ledge. There is not really much you can do. I tried using a flag to go into the grooves and try to push it down, but that also didn't really work well than I expected, so I ended up using this round hook to just do as well as I can do. Eventually the lock did open. Now let's take a look at the sidebar, which is nothing really complex. It's just standard sidebar. There are some kind of grooves which I do not really know the purpose of. These two grooves, this one and this one, is for the springs obviously, but this one and the upper two grooves, I have really no idea why they're there, but that's that. Now, some final words, basic approach of how to pick this lock. I used a bottom of the keyway tensioner on the upper side of the lock. I really tried a lot of combination of tensioners and the picking directions. I even tried putting the lock in this orientation to push it like this, 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 and this. Basically, depending on how the sliders are installed, you have to pick in 4 directions. On this side, the slider that you have to lift up, you have to go in an angle like this. If you have to push it down this angle, in this side, this, and this, so it becomes some sort of like this slanted X shape. Now, I'm not really used to pushing pins down, so this was really, really tricky, and my lock had a total of sliders, 16 minus 11 sliders, and there were 1 slider here and 2 slider here that have to be pushed down. So that was the minimum. If I flipped it like this, that would be much worse. So I ended up finding a orientation that I was most comfortable with. Like I said, I tried this, but this was just way too awkward, so I couldn't really do anything about it. Now I did use a BOK tensioner, which was taking the least space of the keyway, but it still does take up space. If you are pushing this side, you can use room as much, but if you're pushing this side, the tensioner takes up some of the space that you can use, so it's more trickier. And if you push hard enough, while levering, you can also kind of apply force to the tensioner, which can sometimes screw things up. So that's a risk. Anyways, if you have picked a U9, you will basically know how to pick these kind of locks. The false gates are luckily more forgiving than U9. If you basically lock up hard in a false gate of a U9 lever, you basically have to restart. If you try to escape from that false gate, you basically drop almost everything. On this lock, it's more forgiving. I believe it's because they do not bind hard enough. First, they are not that deep compared to false gates in U9, and secondly, this lock has 2 sidebars and a lot more elements on both sides, which slowly makes you turn the core more slowly, meaning that the biting false gates will actually not bite that hard comparison. So you can feel the gates that start to bind and you can pick it out of it. So that's a little bit more easier than U9 compared. Now they are sprung sliders, but you really can't jiggle test them well. There are 2 reasons. One, because that angled space is really just hard to land your pick on, and secondly, these springs are really, really weak. You basically do not want to jiggle test them. I tried them with a very pointy deep hook, which kind of works, but the amount of spring force is really weak to feel, so it's not really effective and efficient to do. Instead, you basically just scrub the sliders like you would do in a U9 or when you're picking a medical, something like that. The sliders that are set will basically move freely on this axis. They will move freely and they will make this rattling noise. Basically, it will feel free. It won't feel binding. If a slider is binding, if you scrub, you'll feel resistance, a dull noise. It's better off to actually feel this motion rather than just listening with words, but yeah, you have to test them like that. At the beginning part, things will not feel clearly, like all these locks do. They will not bind harder even if you use really strong tension. Testing can set stuff. You just lift and they get set, but they don't really give a distinctive click or feeling. So just keep testing all these sliders until something tightly binds, and then you pick that one and you repeat until it opens. Now, Something to add is that I did not really feel that they clearly isolate. They do isolate in some way. For instance, I gave counterclockwise direction tension, and the levers on this side fully set earlier than the levers on this side. But they do binding the stars here, but after picking some levers on this side, I had to work on this so that I can lift them into a either true gate or false gate. That allows the core to turn more and to bind the sliders here and to repeat. So you kind of have to ping pong around the 4-axis directions. So the lock doesn't really clearly isolate, which I think adds the difficulty of picking this. Anything more to add? Let me see. Yeah, it is not hard. I mean, it is kind of hard to overset if you pick this lock normally. However, there are states on early picking when you don't really feel anything binding. They actually really don't bind hard because the core isn't really turned that much. So you have a possibility of overlifting a very low lift slider. If you do that, basically you'll have to reset because relieving tension is going to drop almost all of the sliders that you set. So you have to really be careful, and you have to give a little bit of moderate tension. Weak tension on the early side won't make anything bind, so you have to crank tension a little bit up after you get some core movement. You'll feel that after you pick certain amounts of sliders. If they are all in a gate, either true or false, you'll feel the movement of the cores clicking a little. That means you have some progress going on. Picking out a false case is basically if you find a lever that you already lifted start to bind, is likely a high lift that is currently stuck on a false gate. If that happens, you basically locate your pick directly under and try not to slip, secure your pick, and slowly release tension while still lifting on. If it clicks, then you crank up tension and lift it again, and you lift. Basically a way like you would pick gins in a assisted floating method, like in Gin Twins 6K, stuff like that. You basically have to slowly relieve tension until it lifts, because you can't really force them out of the false gate. They still do bite hard, not like very hard, but they still do bite quite hard. Yeah, I got that covered. And pick selection, I mentioned I used a thin 15,000s hook that was pretty short. You don't really need a deep hook unless your bitting is like really, really extreme, but fortunately my bitting was not that extreme, so yeah, that's also that. Also, the 0 label sliders are the max lifts. I had a total of 2, one on the very front side of this and one on the upper side of this side. If you do identify that it is a max lift slider, it is going to be easier to preset that before it binds hardly on the false gate, because the max lifts are most likely to drop quite a lot of set sliders when you try to escape from the false gate. So a good measure of picking that is that you pick some levers, get some core movement, and that max lever will start to bind, but not too hardly that you can just click into the false gate and keep lifting until it goes past the false gate and into the true gate. That is like kind of presetting, because if you work on that slider a lot later after the core has turned quite a lot, it will bite quite hardly into the false gate and you will lose some progress while lifting that, which happened to me on few of the attempts that I was trying to pick this. Also, if there is a max lift lever on the most rear, that is probably going to be one of the most trickiest pick, because I said earlier the innermost rear elements are going to bind quite later on the phase of the picking, and if that is a max lift, you're going to basically almost certainly you can't preset that, so you're going to go into the false gate, and if you relieve tension to escape from the false gate, you're basically going to drop everything on the front. Yeah, that's also a possible risk, but anyways, I was able to pick it, so not that hard. Okay, I think I covered everything that I can. The video was quite janky, angle was not good, I kept dropping things, but I think I covered everything that I can. I will work on a text write-up about this lock in general, so that is also something. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 11 sliders total. 5 are missing. I believe MIWA only pins this lock into a full 16 sliders if it is from a mastered system. This is not, these all sliders are not mastered, but they do offer a master system for like large buildings, and I believe they are going to use mastered sliders and populate all 16 chambers if you order as a mastered system. This was just a normal order, and they pinned up to the 11, not all 16. So the keys were also not cut, so likely this is the standard issue order from their perspective. So yeah, that's also that. Yeah, I don't think there's anything really more to add. Yeah, this was already going for way too long. I think I picked for almost 20-30 minutes, which was about the same time span like I spent before trying to pick this. So yeah, I believe this is a public first pick and gut explanation of the MIWA WR. I hope you enjoyed, and I'll see you later.